Hello everybody. Once again I am here with you for the another part of this modulation and demodulation. Now in this session we will see expression for the FM voltage. Already we have seen what is mean by to be amplitude modulation, types of modulation, and in which how the amplitude is going to be vary in amplitude modulation. Now in this session we are focusing on expression for the frequency modulation voltage expression. So no doubt, as far as the frequency modulation is concerned, no doubt amplitude and the phase will remains constant. Only variation or the rise will be there in the frequency. Now as we know, this is what the modulation for the frequency modulation is going to be there. And as regularly frequency modulation consists of varying the frequency of the carrier voltage uh, in accordance with the instantaneous values of the modulating voltage, and the amplitude and the phase will remains constant. As far as this is an advantage, because whatever the amplitude modulation itself is going to be concerned, there is very difficult to define actually what is the modulated signal and the noise is to be there in amplitude modulation, or what is the exactly the electrical or any statistical or any atmospheric noise is there. And this is the actually difficulty in the amplitude modulation part is there, and this frequency modulation overcomes this type of the drawback in the modulating signal, and that's why it is having much more in advantages as compared to amplitude modulation. So let's have, this is what the modulating voltage is given as regularly em is equal to em cos of omega mt. Here as it is concerned with the here em is nothing but your amplitude, as far as omega m is nothing but to be angular frequency of the modulating voltage. As regularly again we know the carrier voltage is given with the ec is equal to ec sine of omega ct, sorry, omega ct plus theta is there. And in this case when we can say as yes, this is, yeah, this is what the ec sine of omega ct plus theta. ec is the amplitude of the carrier voltage, omega c is the angular frequency of the carrier voltage, and the theta is nothing but to be a phase is there. So modulating signal is going to be added or the somehow affecting the frequency. Now let we know the omega ct plus theta is given with the phi, where the which is the total instantaneous phase angle of the carrier voltage, and therefore ec, the expression will be written as ec uh, small ec is equal to ec sine of phi, where the phi is nothing but to be omega ct plus theta is there. But again we know that omega c, the angular frequency, is nothing but to be d phi by dt is there as the phase of relationship. And the after the frequency modulation, the frequency of the carrier no longer remains constant, it goes on varying. Therefore the frequency of the carrier voltage after the frequency modulation is given as ओमेगा इज इक्वल टू ओमेगा सी प्लस के एफ ई एम. म्हणजे याच्यामध्ये काय होते की फ्रिक्वेन्सीमध्ये हे मॉड्युलेशन ॲड होते आणि फक्त फ्रिक्वेन्सी व्हॅरी होते, आणि फेज आणि तुमचा ॲम्प्लिट्यूड रिमेन्स कॉन्स्टंट. सो आय कॅन राईट दिस एक्सप्रेशन ओमेगा सी प्लस के एफ ई एम कॉस ऑफ ओमेगा एम टी, where the kf is the proportionality constant, and again which determines the maximum variation in the frequency, no doubt, and given a single strength em signal strength, that is em. Now integrating this above, phi is equal to omega dt, then this omega is somehow written that omega म्हणजे फ्रिक्वेन्सीमध्ये जो फरक पडायला, मग त्या फ्रिक्वेन्सीला इंटिग्रेशन मॅक्सिमाइज व्हॅल्यूपर्यंत जर म्हणलं आपण, तर it will be phi is equal to integration omega dt. So putting that value of omega, that is omega c plus kf em cos of omega mt dt, and when we simplify it, that will give us value omega ct plus kf em upon omega m sine of omega t plus theta 1, where theta 1 is nothing but to be a constant of integration, and it is somehow representing the constant phase angle, and as the phase remains constant in the frequency modulation, and that's why it is the theta 1 is having. Now it plays no part actually in the modulation as far as the frequency modulation is there, and the frequency modulated carrier voltage is given in this fact, that is E is equal to EC sine of omega ct plus kf em up into 1 upon omega m sine of omega mt is there. So this is what the expression for the our frequency modulated voltage is there. No doubt, as the frequency modulation is going on, only the frequency will goes on varying, phase and amplitude remains to be the constant. If you look at this, amplitude remains as it is, and the phase have no part playing in this frequency modulation, and therefore this expression will be sine of omega ct plus kf em 1 upon omega m sine of omega mt is there. So this is what the frequency modulation voltage expression. And again, thank you for joining this session. Be at home and be safe. Thank you.